All right, so today we're going to talk about inverse trig functions. But before we get into the trig part, let's talk about what happens to let's just talk about inverse functions. It's been a while since we've seen inverse functions. Okay, so let's start with our good old favorite f of x equals x squared. Remind me what that looks like. Parabola with a vertex at 0, 0, opening up, right? Okay, so parabola, vertex at 0, 0, opening up at 1 over, we're 1 up, and 2 over, we're 4 up, and we quickly sketch our graph. Okay, what is the inverse of x squared? If you want to undo x squared, what do? We square root it, right? So if g of x is the square root of x as a function, what does that guy look like? Yeah, you're giving me the movements, right? The square root of 0 is 0, the square root of 1 is 1, but we don't like to take the square root of 2, do we? We try to take the square root of 4 because we know that the square root of 4 is 2. We like to pick numbers that are handy and useful to us, right? Okay. So whenever we talk about the square root function, we're talking about the top half of a parabola that would potentially open downward if we did the minus square root of x, right? Okay, so tell me about cube root. What does the cube root of x look like? Or maybe we'll do the other part first. Let's do the cubic. Yeah, it kind of looks like tangent, doesn't it? Okay, at 0, the x 0 cubed is 0, right? 1 cubed is 1, and negative 1 cubed is negative 1. But what happens at 2? 2 cubed is 8. So we got to go clear up here all of a sudden. And negative 2 cubed is negative 8, right? So here's our cubic. And the inverse of a cubic is cube root, right? So when we graph that, we like to graph the cube root of 0, which is 0, the cube root of 1, which is 1. But what happens at the cube root of 2? Not nice, is it? So we want to use the cube root of 8. Then we can go too high. And the cube root of negative 8, then we can go out here. And we know they're inverses of each other because the reflections across the line y equals x, right? So basically all we're doing is switching the x and y coordinates around and getting the inverse. So far so good? Okay, now let's think about what happens with sine. Okay, you all know by now that the sine wave gets to go as high as 1, as low as negative 1. And we like to use radians because it makes our life easier. We have a 2 pi for our full period. And it starts in the middle, goes high, back to the middle, goes down, back to the middle. Starts and ends high and makes this lovely sine wave. Do a very good job. My negative 1 and my 1 are not symmetric, but you have the general idea. Okay? Let's think about what that would look like if we tried to find the inverse of that. Now our x-axis will have values that are on the y-axis. Pi over 2, pi, 3 pi over 2, 2 pi, and our x-axis will now have the y's value, right? We'll get to go as big as 1 and as small as negative 1. Okay, so what's this going to look like? Still 0, 0, right? What's the sine of 2 pi? The angle whose sine is 2 pi is going to have a value of 0, 0, 0's at the pi's, right? And at pi over 2, it gets to be 1. 3 pi over 2, it gets to be negative 1. So it would look something like this. Kind of strange, huh? Go low here, go right here, left here, right here. Do a good job of making that. Go through the right spots. That would help. I'm going to go to here, and then through here, and then eyes here and back. Get the idea? It's not a very good graph. Okay? So all we're doing is reversing the x and the y coordinates. Our x-axis is now has what was on the y, and the y-axis has what was on the x. So here's my question. Is the inverse sine going to be a function? Emery's shaking his head no. Why not? Yes, because of the vertical line test. For every x, we have lots and lots of y's, right? For every x, we have to have exactly one y to be a function. And so if we're trying to graph it this way, it's not possible for this to be a function, the inverse sine to be a function, unless we restrict it and say we only get to use certain values. Does that make sense to everyone? Okay, just like we restrict the square root to only be defined when x is positive, right? And we don't say a negative square root of x. Okay, we only get the one values. Okay, so here we go. This is what we're talking about today, inverse sine function. Okay, in order to be one-to-one, to pass the horizontal line test, we have to limit the domain of the inverse sine. Because sine goes on and on and on and on and on, we need to have some values where sine gets to be between 0 and positive 1. And we need to have some values where sine gets to be between 0 and negative 1, but we don't want the repetition. So we restrict the domain of the sine function to be only between negative pi over 2 and pi over 2. That way we get all of our negative values, negative 1 to 0, and all of our positive values, 0 to 1. We write the inverse sine as y equals, and we use a negative 1 power. It looks like a negative 1 power, but the inverse sine of x, or y equals the arcsine of x. So you're going to see both notations, and they'll show up. Our book tends to use the second one, but sometimes on the ACT or SAT you'll see the word arcsine or arccosine or arctangent. That's what they're talking about there. So far so good? So then what we're going to do is we're going to take these values and we're going to flip them. Replace the x with the x and the y with the y. Okay. So far so good? Okay. X with the y and the y with the x. So, first thing we want to do is decide, did I miss a slide? I think I did. Did I not? I didn't graph it? Okay. Okay, we'll graph it in just a moment. Okay? So we want to, first of all, decide if it's possible to find the exact value. Or find the value of the arcsine, and if possible, the exact value. Okay? So I want you to picture that table that we've been memorizing and learning. Okay? Now ask yourself, on that table, is there a place where the sine of some angle is 1/2? What's the degree, what's the measure of that angle in degrees or radians? It should be over 2. Where's the sine equal to 1/2? Which angle has sine 1/2? 30 degrees would be 1, so pi over 6, right? And then we also said that a 30-degree angle in the second quadrant would also be positive, right? But because our arcsine is restricted to be between negative pi over 2 and pi over 2, we only have to talk about the 30-degree angle in the first quadrant. Does that make sense? Okay, so this is going to be 30 degrees or pi over 6. Sine of 30 is 1/2, so the angle whose sine is 1/2 is 30 degrees. We're looking for that angle back. Okay. Now, and again, in that table, if you picture it in your head, is there a place where the sine is square root of 3 over 2? $60 degrees, okay? And so it would be a 60-degree angle, or what would that measure be in radians? Pi over 3. So far, so good? We're just going backwards now. Instead of me asking you, what is the cosine of 45 degrees, right? We're going to ask you, where is the cosine 45 degrees? What angle gives you a cosine of 45 degrees? Okay? How about the inverse sine of the square root of 3? Do we recognize square root of 3 with sine? Is that anywhere in our table? No. So we want to say, wait a minute, let's try and put that in our calculator then and see if that's going to, what that value is going to be. When they say exact value, we want to say, hey, these are some things that could potentially be in our table that we need to know. Okay? Those special right triangles that we need to have their values memorized. So we ask ourselves, where's the inverse sine going to be the square root of 3? Let's grab our calculator. And clear. All right. So angle whose sine is, everybody remember when I told you that this little guy, sine to the -1 power, is not the reciprocal of sine, it's not the cosecant. We have to do 1 divided by the sine in order to get the cosecant. So this is now what we're looking for. We're looking for the angle whose sine has a measure of. Okay, so we're going to go second sine, and then we're going to put in a square root of 3. And what happens? What happens? Error. Why? It's undefined there. Why is it undefined? We can't go anything. So this, what is the square root of 3 roughly? 1 point something, right? Does sine ever get to be bigger than 1? No. So is there ever an angle that's possible that the opposite over the hypotenuse, when the hypotenuse is the biggest side of a triangle, could be more than 1? No. So they're going to try to trick you and make sure that you can think about this stuff, right? The square root of 3 is never going to be something that we can use with sine or cosine. We could with tangent, but not with sine or cosine. That make sense to everybody? So if you get an error, it's completely possible that you could have that because this is not out of the domain. Okay? There is no such thing. Does not exist. Okay? So far so good? Okay, next one. So let's graph that arcsine. Okay, and we're going to use some numbers that we can kind of work with that we know fairly well. Okay? So before we were saying pi over 2, sine of pi over 2 was negative 1. Sorry, negative pi over 2 is negative 1. Sine of pi over 4, negative pi over 4 will be a negative square root of 2 over 2. Sine of a negative pi over 6, a 30-degree angle in the fourth quadrant, is going to be a negative 1/2. Sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2. And sine of pi over 2 is 1. Does anybody remember what square root of 2 over 2 was as a decimal? 0.7. So we're going to think about this as negative 0.7 and this one as a positive 0.7. Okay. And now our y values are going to be the radian axis. Okay, the y-axis is the radian axis for the arcsine or arccosine or arctangent. So we'll need to have a negative pi over 2 to a positive pi over 2. And we'll need a positive 1 and a negative 1 on the x-axis. Kind of like graphing logs. Remember how those were kind of weird, right? Versus exponential, same idea. Okay? And so we're going to go halfway between will be a pi over 4. And we'll have a half. So when we are negative 1 for x, our y is going to be a negative pi over 2. Sorry, went the wrong way. When we are at a negative 0.7, we're going to be at a negative pi over 4. When we're at a negative 1/2, we'll be at negative pi over 6. So where's pi over 6 in relation to pi over 4? A little bit above it, right? 15 degrees above it. Okay, so at negative 1/2, we're at negative pi over 6. At 0, we're at 0. At 1/2, we'll be at pi over 6. At 0.7, we'll be at pi over 4. And at 1, we'll be at pi over 2. And so this is what the arcsine looks like. And it has a hard stop. It doesn't keep going, because if it kept going, we wouldn't have a function anymore. It's not one-to-one. So far, so good? Okay. It's kind of like turning a paper and graphing it just from negative pi over 2 to pi over 2. So far, so good? Questions on this one? All right, it's hard to wrap our minds around it. Exercising our brain today. Okay, other inverse trig functions. Okay, so think about what happens with the cosine. Okay, sine was positive in the first quadrant, negative in the fourth quadrant. So we could restrict it from negative pi over 2 to pi over 2. What's happening with cosine? Well, cosine starts high, ends high. In the middle, it's at the bottom. So we just want from the high to the low and nothing else. Make sense? And we can't be like sine was, arcsine. We can't say, let's just go from negative pi over 2 to pi over 2, because then we only get our highs. Does that make sense? We only get our positive values. So the cosine is going to be restricted, the inverse cosine will be restricted to 0 to pi. first and second quadrants, because we get some positive values for cosine and we get some negative values for cosine. Sine's positive in the second quadrant. So far, so good? Okay. And the tangent, okay, because the tangent looks like this. I think I have a picture of it. Okay, well, here's the arc cosine graphed. Okay, at pi over, so at when we're negative 1, when we're here at pi, we're at a positive 1 when we're here at 0, and in the middle, when x is 0, y was pi over, or when x was pi over 2, y was 0, so when x is 0, y is pi over 2. This is the cosine function. So far, so good? Okay. Let's think about what tangent looked like. Okay, tangent says, hey, I've got a 0 here and an asymptote at pi over 2. And again, another asymptote at negative pi over 2. So we can get one full complete cycle, both the highs and the lows, between negative pi over 2 and pi over 2, just like we did for sine. So sine, the arcsine and the arctangent are going to have the same range. Okay? But the cosine has to be different between 0 and pi. Make sense? Okay? Now, our goal and our whole hope is not that you spend a ton of time graphing these things. We want you to graph them so that you have some practice and are used to them and understand what they are. But the biggest thing is going to be to solve problems using them. Does that make sense? Okay? So arctangent, well, at pi over 2, we had an asymptote. At negative pi over 2, we had an asymptote. At 0, we had a 0, didn't we? Okay? But then what happened when we were with tangent, when we were at maybe pi over 4? We're up here at 1, aren't we? So when we're at 1, we'll be at pi over 4. And at negative pi over 4, we were down here at negative 1. So over here at negative 1, we'll be at negative pi over 4. Okay? Questions on this one? All right. So, if possible, we want to find the exact value of these guys now. Just like we did with arcsine, we want to see about arctangent and arccotangent. So ask ourselves, do we know an angle where the cosine is the square root of 3 over 2? 30, right? 30 degrees is where the cosine is square root of 3 over 2. This is a positive square root of 3 over 2, so we can say 30 degrees. What would that be in radians? Pi over 6. So some of the assignment that you're going to do is going to be that quick. You look at it, you recognize it, you write it down. Okay? Do we know a place where the cosine is negative 1/2? In the third quadrant and in the second quadrant. So where is the inverse cosine restricted to? First and which one? First and second quadrant, right? Between 0 and pi. Okay? So because the cosine is restricted to the first and second quadrant, the second quadrant is where we're going to get our negative, aren't we? Okay? So what is which measure would it be for cosine? 1/2? Nope. That's square root 2 over 2. 60, right? Cosine 60. Cosine of 60 is 1/2. So we want a 60-degree angle in the second quadrant. So what does that measure? So 60 degrees in the second quadrant is 60 degrees short of 180. 120. What's the radian mode measure of that? One pi over 3, 2 pi over 3. Okay, so do you see why you need to know your table? Inside, outside, backwards, forward, those special angles? Sine of 30, sine of 45, sine of 60, cosine 30, cosine 45, cosine 60, tangent 30, tangent 45, tangent 60. Okay? How about this one? Do we recognize a square root of 3 over 3 for the tangent? What angle has a square root of 3 over 3 for tangent? 30, all those 3's, right? So it's positive. That means we're in the first quadrant, 30 degrees. And what is 30 degrees in radians? Pi over 6. It's a 30-degree angle. It's got a 6 in the denominator. It has to be in the first quadrant because we've restricted arctangent to be just in the first or the fourth quadrants. So we're good. Where's the arctangent going to be 1 at? Same place where the sine and cosine are the same. We divide sine by cosine, we get tangent. Where's the sine and cosine the same? First quadrant, 45. So 45 degrees is the same thing as what in radians? Pi over 4. 45 has a 4 in the denominator. Okay? Make sense? Questions? All right, here we go. Next piece. Now we have to use our calculator. Okay, we want to figure out where is the tangent, what angle has a tangent that has an opposite over adjacent of 1.9. Okay, which angle has a tangent of 1.9? Just break out your calculator. Graphing scientific doesn't matter. Okay, angle whose tangent is 1.9. Okay, so we want the second tangent, inverse tangent, the arctangent of 1.9. And what do we get? I got 62.24. Okay, what is that in degrees, right? My calculator happens to be degrees. Okay, so if your calculator came up with something different, it's entirely possible because you may be in radian mode. So if we go back to mode and we change it to radians and then quit, and I want to do the same thing in radians so I can see exactly what I had, but in radians, I go second entry, so I don't have to retype it again. So find the angle whose tangent is 1.9 in radians. I press enter, and it's 1.086 radians. Yep, the inverse. Kind of like a -1, but remember, these aren't reciprocals. Yep, these are the inverse buttons, so you get to use these now. Okay, so arc in front is the same thing as sine to the inverse, cosine inverse, tangent inverse. And we won't do an inverse cosecant and things like that. Okay, so far so good? Okay, next one. Arc cosine of a negative pi over 3. The angle whose cosine is negative pi over 3. Doesn't make sense, does it? It's an error, isn't it? Why? Well, we're taking pi over 3, which is an angle measure, and we're trying to find the angle who has this angle measure. That doesn't make sense, does it? So they're going to throw that stuff in and see if it's nonsensical to you, to see if you can say, hey, wait a minute, this does not exist. It's not possible. Okay, we're asking for an angle whose cosine is an angle. And what is pi divided by 3? something bigger than 1, right? Yeah, pi over, well, this is 60 degrees, right? So we can do the cosine of 60 degrees or cosine of negative 60 degrees, right? But we can't find an angle who has an angle measure that's an angle measure. Okay? Make sense? And this is negative 3.14 divided by 3 is going to be something bigger than 1 or something smaller than negative 1, right? And so it's not possible. So this does not exist, not possible, whatever you want to write it. Okay? How about inverse sine, the angle whose sine is a negative 0.919. Second sine, negative 0.919, because the arcsine is only defined in the fourth and the first quadrant, negative pi over 2 to pi over 2. We're only going to get one value here. Does that make sense? Okay, and that's going to be a negative 1.166. In radians, what was it in degrees? Negative 66.78. Okay, so next question that comes up is, do I have to give it in radians or degrees? My answer is I'm going to have them both, so unless the directions tell you otherwise, I'll key it with both of them in there to see if you have one or the other. Okay? But you'll have to be cognizant of, do I need to be in radian mode or do I need to be in degree mode all throughout your test and so forth. So far so good? Okay, so here's the easy part. Inverse properties of trig functions. When x is between negative 1 and 1 inclusive, and y is between negative pi over 2 and pi over 2 inclusive, then the sine of the inverse sine of x will be x, right? It's like taking the square root of x squared. We just get the x back. We're doing the inverse of the particular trig function. And the arcsine of the sine of y will be y. Okay? We're taking finding the angle whose sine has a specific sine that is y, right? And we're just going to get, they're negating each other. Okay? Same thing with the arc cosine. Cosine of arc cosine of x will be x. Arc cosine of y will be y. Arctangent of tangent of y will be y, and tangent of arctangent of x will be x. Does that make sense to everybody? Easy peasy, right? So if we give you something like this and say, what's the tangent of the arctangent of 23? You're going to say 23. But if we say, what's the sine of the arcsine of pi? You're going to say, you're going to want to say pi, right? But this is not possible. Why is it not possible? Can we find an angle whose angle is pi? No. Okay. So this one's not possible. We cannot take the inverse sine of 3.14. Too big. Not even in our domain. So far, so good? Okay. And the cosine of the arc cosine of a negative 0.82. Is that possible? And what's the answer? Okay. So good? Some of these are going to be so quick, you're going to be like, wow, easy problems after graphing all those functions, all those trig functions. Okay, but now we want to find the sine of the arc cosine of 2/3. Okay, so now we don't have two functions that are inverses of each other, just pull the number out, right? But what does that mean? We want to take the sine of the angle whose cosine is 2/3. Sine of the angle whose cosine is 2/3. Adjacent to hypotenuse 3. Everybody agree that that would be an angle whose cosine, if I did it to scale, was 2/3? Okay? And if I want the sine of that angle, what do I need to do? Opposite over hypotenuse. So I need to know my y value. I've got my x, I've got my r, right? What am I going to do? Pythagorean theorem, 2 squared plus y squared is 3 squared. So 4 plus y squared gives me 9. Y is going to be the square root of 5. So the sine of the arc cosine of 2/3 is going to be, what's the sine of this angle? Yep. Feeling good? All right. So the graphing's the hardest part. We just have to wrap our minds around it. But the rest of it, we just don't let them trick us. Don't ask me for an angle of an angle, right? Don't ask me to take the inverse sine or inverse cosine of something that I can't do, because it's out of my range of -1 to 1.